In this problem, we need to find a geometric progression whenever the sum to infinite terms is 15 and the sum of the squares of each term is 45. So let's begin. We'll first specify the first term and the common ratio. We're going to specify the first term by the letter A in lowercase and the common ratio by the letter R in lowercase. So it's given here that the sum to infinite series, that means S infinity, that's 15. And the sum of the squares of each term is 45. So if the first term is A, the next term will be A times R. The third term will be A times R square. So this sum, so we have to square it. Square of each of them. So that adds up to a value of 45. So we need to find out the geometric progression. So let's begin. We know that the sum to infinity or the sum of the infinite terms of a geometric progression is given by the first term divided by 1 minus r equals to 15. If we square both sides, we're going to get a squared divided by 1 minus r whole square equals to 15 squared will be 225. Now, here we have a squared r squared. So the first term, if our first term a, this is a squared. Don't get confused with this a equals to a squared. Here I'm only using it as a representational purpose. So this is our first term and the common ratio that's equals to a r whole square divided by a squared. So that will be equals to r squared. Now the sum of this particular infinite series, that will be the first term, which is a squared divided by the common 1 minus the common ratio, which is 1 minus r squared. This value is equals to 45. So we're going to label this as equation number 1 and this one is equation number 2. So let's divide equation number 1 with equation number 2, which will be a squared divided by 1 minus r whole squared multiplied to the reciprocal of a squared over 1 minus r squared. So we have 1 minus r squared divided by a squared. So this is equals to 225 divided by 45. So a squared and a squared gets cancelled. And we have 1 minus r squared divided by 1 minus r whole squared, which is simply 1 minus 2r plus r squared. So this is equals to, so we have 5 times 45 is 225, 5 times 9, 9 times 5. So that means 45 times 5 is 225. So we're left with 5. Now we will have 1 minus r squared equals to 5 multiplied to 1 minus 2r plus r squared. So that's going to give us 5r squared minus 10r plus 5. So we will transpose 1 minus r squared to the right hand side and we can rewrite the equation as, so we have 5r squared plus r squared. Then we have negative 10r plus 5 minus 1 equals to 0, which gives us the quadratic equation 6r squared minus 10r plus 4 equals to 0. Now dividing each terms by 2, we have 3r squared minus 5r plus 2 equals to 0, which is going to give us 3r squared minus, so we're going to split the middle term. So the 5r can be represented as negative 3r minus 2r plus 2 equals to 0. So we're going to combine the first and the second term by taking 3r as the common factor. So that will get multiplied to r minus 1. Then we're going to combine the third and the fourth term by taking negative, this is 2, negative 2 as the common factor. So 2 will be multiplied to r minus 1. That's equals to 0. So we get r minus 1 multiplied to 3r minus 2. So this is equals to 0. And this gives us the value r equals to 1 and r equals to 2 over 3. However, we cannot consider r as 1. R cannot be equals to 1 because in an infinite geometric series, we have the condition that the absolute value of r is less than 1. So that means we can only have r equals to 2 over 3. So let's now use equation number 1. So in our equation number 1, we had let's not use equation number 1, but we'll use this particular equation, a divided by 1 minus r equals to 15. We have a divided by 1 minus r equals to 15. So here, when r is equals to 2 over 3, so we have a divided by 1 minus 2 over 3 equals to 15. So a will be equals to, so here we have 1 minus 2 over 3, so that's 1/3. So we'll have 15 times 1/3. So that gives us the first term as 5. So now we have obtained our first term, which is 5, and the common ratio is 2 over 3. Now we can easily define our geometric progression. Thus, the geometric progression will be, the first term is 5, the next term will be 5 multiplied to 2 over 3, so that's 10 over 3. Then we have 10 over 3 multiplied to 2 over 3, so that becomes 20 over 9. Then we have 20 over 9 multiplied to 2 over 3, so that's 40 over 27. So this is going to be the required GB.